dash 9. And the paper is crooked. So let's fix that. It's what's our agenda? I guess there's one agenda. Look, of course, course, to Wednesday. Okay, not reasonable. Huh. I guess it is. Okay, so what is, I started this Zoom for teaching, I don't know, 4 years ago. The COVID had disappeared and faculty were going back to their regular teaching form. So I thought, well, maybe I can help reduce a little pollution by taking a few cars off the street. If I Zoom my class, and that was the only class someone had, that person could stay home the whole semester and not make the commute. Yeah. Okay, so I hope that works. I had two students, I don't think they knew each other, but they emailed me from India saying my flight got canceled and I have to reschedule it, but I won't get there until the second week. And so I emailed them back and said, well, I'm Zooming this. You can just take the class where you are. And apparently they did. And both of them independently told me I never rescheduled my flight, so I never did go. But I got full credit because you were willing to Zoom it as well as do it in person. So I'm trying to make a convenience. Um, Zooming is supposed to reduce some traffic pollution, and it's a convenience to those at a distance who can't get here. Um, I had a student lived in Bakersfield, drove to Fullerton the night before class, went to class, and then drove all the way back to Bakersfield. It's like a 7-hour drive. So, but this was about 2019. So he could have benefited from Zoom teaching. Now, the administration says that I have to be in the classroom a certain fixed number of days. I think it's 80% of the days. Uh, but there's no rule on students. Just the instructor has to be present in a classroom physically at least 80% of the time. Okay. You probably didn't know this when you signed up for the course, but that's okay. You discovered it later. And the role, just relax, everyone. The role, get it. Why do we have, why, why is 240 here? I know the senior faculty are going to give you a high-powered answer that this is the fundamental hardware components of of everything you do hereafter, and yada yada yada. So no, my answer is that when your goal for getting a bachelor's degree, majoring in computer science, is that's the union card that gets you in the door for lots of jobs. So occasionally, at the job interview, you go through the first hour of interview with some HR goofy gimp person who asks you all these questions. What's your hobbies? What do you like to do on the weekend? But then it comes down to real brass tacks, and someone switches places, and that's the technical interviewer. And the technical interviewer could ask questions all over the map. That's why you study a breadth of course, a wide breadth of courses. Occasionally, that person asks questions about assembly. Um, so I see it that if your interviewer starts going down the assembly track, you'll be well prepared to answer uh, those kind of questions. The last student told me about this said I got asked all about Little Indian to explain the whole thing and why we do it. And that was the interviewer's question. Uh, she said, I explained everything I learned in class, and it seemed like they were pleased with me. So, why is it here? I know it's getting an A is an intermediate milestone. Get a get past. I can't spell it, everybody. Past the job interview. After they like you enough to go bring you in for an interview, and then that second part is it could be all wrong. It could be a second part could be about uh, website construction. We don't know, but you have to be prepared for everything. Okay, so I I think I came to conclusion a few days ago. I need a new term. Okay, the new term is supposed to, in in a word or two, encompass the style of learning that we have. So what I chose, I chose assembly culture. Culture. And specifically assembly culture of 240, but I'm not going to write that out. Assembly culture. Okay. And so assembly culture is the term that it embraces everything that we've done in a standardized way. Um, I'll expand on this, and this leads to our test coming on Wednesday. If you look at some assembly code online, not a snippet like they're trying to illustrate how to use string lengths or something, and you get 5 lines. No, I mean real developed work that's going to solve an application problem. So assembly code across the world looks like junk. Elsewhere. Not that it runs wrong, it just looks horrible. It looks like junk. Illegible, unreadable, not understandable. It's so in our culture, we've decided that we'll all as a miniature society here, we all program assembly functions in the same style, in the same layout. So this is to bring organization out of chaos. Same style. And most of you are doing it. Most of you adopted it from that first week. The same style is, I'll be fast because this sounds repetitious. License at the top, author here, author's contact information, program purpose, and the program description of development machine, target machine, the software, operating system, version numbers, all that. Okay, and then declarations. You see, declarations, and then segment dot data, dot BSS, dot TXT, and within TXT, it's within blocks. A block is a logical unit that accomplishes one single little purpose, and that purpose is described up at the top. I recommend you separate blocks with a blank line, and then the next block describes one specific little logical function. Compute interest rate on principal at X interest rate or something. See, that computation probably takes 4 or 5 assembly statements, and it's one nice block. So block after block after block. The rest of the world doesn't do this. And you end up with RET at the end of your assembly function. That layout is part of 240 assembly culture. We're all going to do it that way, and it makes it easier for the grader to understand it. It would make it easier for you to show it to someone else, a classmate. They'll understand what you're after. You know, NASM doesn't enforce it. NASM doesn't say that data has to be before BSS. Data could be stuck at the very end, and BSS could be stuck in the middle someplace. I don't program that way, but I've seen programs where it's a jungle. But NASM says that's not my fault. I'll just assemble it anyway. Okay, so our culture. So in the test document on Wednesday, I'm going to say write a program according to our assembly culture that does the following. And I'm not going to name all that stuff. Our culture includes no registers smaller than 64 bits, except in rare cases. I think all semester there's probably been no more than 3 rare cases. One was the function getLine. This was in assignment 5 to use syscalls. GetLine, what were we using before? Oh, fgets is the library function. This one was supposed to be in assembly, and it needed AL register, and that's okay. AL is a 1-byte register, and getLine just needed it. So we make a few rare exceptions, and nothing else. And we haven't used it much, but there's a register R flags. And it's all empty in the upper half. It's just never used. So it's acceptable to use only the lower half. There's certain bit in places, like the second bit and the seventh bit, and I forget, there's a 12th bit, that have some significance to programming. If you never used R flags, but referenced E flags, that's acceptable because it's a special case. But in general, all cases, don't show me ESP. That's out of our culture. That's the top of stack pointer from ancient times before you were born, 25 years ago. It was ESP. It's now RSP. Okay. So anyways, our culture says don't use those. Our culture says don't use floating point unit. I don't want to teach it. It is terribly obsolete. The only place it exists of value is in legacy programs that have to be repaired. Some old stuff written decades ago is written in FPU code, and don't repeat it. It's not worth learning unless your employer assigns you to maintain old software. If it's that old, it's time for the company to rewrite it. But if you got assigned to one of those jobs, then it's time to spend the weekend and learn to use these registers. Okay. Oh, let me look at my list here. We'll get to our test stuff. So on the test, I'm going to use the words like write a program according to the 240 assembly culture that does X, Y, and Z. And then I don't have to name all these things, like don't use FPU, don't make your text segment in blocks that have a title to each block. I just wanted to use that one term, and then everybody knows what it's all about. It's okay. The machine lock on the screen. If I don't remove it, I'll get locked out. Let me log in again. Okay. Then I'm looking at my notes here. Let's find where we're going. If I missed anything. Oh yeah. Okay. So this past weekend, I studied past programming assignments of this semester and kind of extracted important things that happened in each one. And here's a hint. This test has nothing to do with syscall. I think you should not forget syscalls. Who knows what kind of operating system class you'll take, but it's not, syscalls are not on this coming program. Okay. How can I explain? So I tried to extract things. I'm more than trying. I think I did. I extracted principles that appeared in assignments 1, 2, 3, and 4, not 5, and 6. No, 6 I'll put on the concept test. Okay. So then I had to create an application idea. Application is not the educational goal. The application is to compute the driving time to Las Vegas or some real world problem like that. So I think I have 3 of them. I do have three test questions, 3 application questions. And by random chance, you'll get one of them on Wednesday morning. The other 2 sections will have a different applications. It's all, and it's based on things that we've been doing. Our Our culture allows, okay, I'm kind of switching subjects. So there's a test coming that uses what you've learned. Okay. What you've learned is in a file, and I don't remember the exact name. It's something like this. Approved, APPR, ROV, approved instructions. It's a list of all the instructions that have appeared in all the programs since last January until now. Well, I'll lead up to why that GDP is the problem that causes this problem. We have an approved list. Don't, that's our culture. We use that list of approximately 50 of them. Don't send me a program with instructions outside that list. Okay? Now, this is mission critical. If you write a program on Wednesday and it has even one instruction not on the approved list, it's a zeroed out. The fact that it has an instruction that's not out else other than here. So G, you can know that approved list, but it covers everything. I even added two new ones late last night. So if you have an old copy, get a new copy of that list. Okay. Now, GPT. We're not Luddites. We're not so stupid as we reject modern technology. GPT is okay to use. Create programs, software, even assembly software. But here's what I'm afraid will happen is someone will use GPT to create a program and submit it, and it's outside of our culture. And then this person's going to say, but I made it in GTP. It's got to be good, isn't it? No, it isn't good. GPT-made programs don't get any special privileges. They have to meet the same standards as human-made programs. Same standards is a, so that your classmate who doesn't use GPT or doesn't want to use it has equal chance on a level playing field of getting a good score. Your GPT made software has to use the instructions that are on that list. And it has to be in the same culture of these blocks, in the same order. These can't be switched over. BSS and data flipped over. NASM will accept that, but I won't. It's not in our culture. And the body of text has to be subdivided into logical blocks that do stuff. Make sure your GPT program does that. Now, I have an opinion at the end of all this is, I'll give it now. It ain't worth your time to learn GPT to make software. Some other day in the future, go ahead and do that. But it ain't that smart. It just is too dumb to make an organized program. It'll make a chaotic program for you. So, but it's up your call. Okay. It's gonna the programs you submit, whether it's GPT created or human created, they all have to meet the same standard. And the standard is they have to fit in our culture. And our culture is what I've been talking about this morning. Okay. Now, I take it very seriously. If If you use GPT and it makes a pretty good program, but one instruction is not on the approved list, it's all zeroed out. It's not worth it. Uh, Last semester, people kept using the test instruction. It's not approved. Don't use it. It's just it will cause your whole test to get a 0 out of 100. Okay, this is mission critical. It's mission critical stuff. It has to be things that we did this semester, not things you learned in a course someplace else. That doesn't count. I don't really care about what we might have learned someplace else. We're learning this culture, not that culture. Okay, so um, mission critical program, mission critical uh, features. Mission critical means the the objective fails. It just um, a SpaceX rocket that lands in the ocean and doesn't reach this International Space Station has a mission critical failure. The whole thing flopped. Okay, so we have mission critical requirements, and then we have minor requirements. These aren't like um, all instructions. The list. So mid, middle of the run, seg faults. LTF faults. Okay. Um, no code that this is so dumb. No code that fails to compile or assemble. And I don't know why I have to say it. The your handout will have the identification required. Since you were in the third grade and you turned in a paper, teacher says, put your name on the test and turn it in. Sixth grade, teacher says, put your name on this report and turn it in. In the ninth grade, teacher says, put your name on this project and turn it in. And then you get to computer science major. Oh, I don't have to do that. I'll just turn it in. So last assignment, there were 3 in one section. No name, no identification, no anything. So I can't spell the identification. Okay. Missing identification zeroes out the project. That's mission critical. If it fails, okay. It's so elementary. I don't know why it has to be there, but these are things that lead to zeros on the whole project. Why am it's the bookkeeping problem. In a typical class of 30, there'll be 8 blanks on the grade sheet. Those are usually represented by people who are no-shows. They just didn't come to class. But now it's being represented by people who don't sign their software, their source files or their concept file. So now I'm left with 7 people, for instance, blank space. I don't know how to figure out who the unsigned documents belong to. It could be no shows. It could be the other somebody who just doesn't care. I don't know. Okay, so see if I have this. Mission critical. Unable to start a program, unable to start execution, able failure to compile. I don't know if your software is not compiling, everyone. Uh, oh, I should come to that. Send me something that does compile. Um, I'll come to that in a moment. Failure to return to the operating system, use of instructions outside the probe list. So I'm scanning, see if I missed anything. These are, if someone needs it, oh, this was a concept question. If it was asked to produce a convert to integer, and someone kept producing 32-bit integers, the the culture that we're assuming says everything is 64 bits, unless there's some extreme special reason why you need a lesser number of bits. Logical blocks. Okay. Okay. Partial credit. I this is hard to get across. Um, I send you a specification document. You start building the program. After 45 minutes, you look at it and say, this is way too much for me to finish in 2 hours. And that's okay to realize that it's just too big a chunk of stuff to do. But then it's your job to intentionally omit something from the specification I give you, scale it down to less. That means you're going to intentionally omit something that it says you have to do. It's another way of saying it. Something. And I'm okay with that. That doesn't, omitting something doesn't kill it. And that's not mission critical up here. That's okay. Um, you may get, instead of 100 out of 100, you may get 80 out of 100 or 75 out of 100. But the important thing is it runs gently to completion with no save faults in the middle. Okay. In the most scaled down case, I used to call those the Chris Sawyer program. If you look at my specification and you say, forget it, I can't do any of that, make up a program of your own kind that does do something so I can grade it. Chris Sawyer program, I think the guy's 44 years old. So the Chris Sawyer program has a driver and it calls one assembly function, and the assembly function outputs happy birthday Chris 44 times. Happy birthday Chris 44 times. But it runs. So running is great stuff. You turn that and submit it, and I'll look at it and say, maybe it's 20 points, maybe it's 35 points. I don't know. It's not 80 or 90, but it's something. But that wins over programs that don't compile, or programs that crash, or programs that don't make sense. This is a winner. It's not a big lottery prize. It's a small prize. Uh, and I say every semester, scale down hard things to something that's doable, and then that's really respected and acceptable. Okay. Now, scaling it down to the Chris Sawyer program that's extreme. I hope you don't have to do that. Um, take my specification and mentally cross off three of the five things it asks you to do, and do the other two. And, but do them well so it runs completely. Don't turn in a program with a seg fault. If you get to it's 10 minutes before the ending time, the program's making a seg call. Find the function call and comment it out. If there's a call to compute interest, and whenever that's running, it's seg faults, go back and comment it out. When you run the rest of the program without that one, and you'll get a lot of points compared to sending something in the seg faults, because it has logical issues, and there just isn't time to search that problem out. The search for the cause of the seg fault. Okay. Let me see here. Keep your past assignments at hand. Keep assignments. You completed job. 1, 2, 3, and 4. 5 had syscalls. There's no syscalls in your test. 6 is a recommended one. You really don't have to keep that at hand, but you need to keep these around. You'll probably find functions back here that you could just copy and paste them into this programming assignment, this programming test. Because I'm basing it on what you learned back here, and therefore you probably reuse some of the software. If you haven't done all 4 of these, now you have 48 hours to work on it. I don't know which, it's random hit, which one of these will apply to the program you're doing on Wednesday. But if someone's asking me the question, how do I study for the test on Wednesday, I would say make sure that all 4 of these are running in our culture. No extraneous stuff from outside. These are perfect in our culture. And then you studied a lot. You've prepared well for the test. Well, let's see. Oh, I don't see that there's anything I should do. You already know about, we talked about it many times, submitting a link is a zero out. This kills your project. You know why it is. Maybe I never explained it. Here's the old trick from the past. Students working on final exam, the 2 hours are over. So he puts it in the cloud and sends me a link. Okay. He knows that I won't get around to downloading that for another 4 or 5 hours, maybe late that evening. So he gets 4 or 5 hours of extra time to work on the project that the rest of the classmates didn't have. And then I get home, and then I start downloading all the submitted programs from that day. Well, that's a cheat. And to make it fair game for everybody, nobody gets a link, because that's just a sneaky way to get extra time to work on a program, uh, knowing that I can't get to it within minutes after you submit it. I'll get to it later in the same day. Awful cheating. Okay. What else? Macros, none of these require macros, but I've seen some really good use of macros from you students. Macros are not required, but I looked at some of your submitted programs, extensive good use of macros. And you know, we haven't put in the culture yet, but where does it fit? Where do you place the macros? I think the best place is in an include file. That makes it portable. You can just include that file in the next program, and all those macros are there. But it's also legal. Uh, how do I make the after segment DSS? Some people insert the macro here, and then here comes segment text. If you have no intention of ever using that macro in another program, you can just embed it right there, and I think that's okay. It's I've seen it done, and it works satisfactorily. I'll leave it your choice. I think the include file, because you can easily port it to the next program, is the best place. Let's see what else is on our list here. Macro, yeah. Oh, when should you use a macro? What indicates a macro? You scan your segment text, and if you see two blocks identical, maybe except for data, but they're computing the same thing, then a macro, it could be, a macro could be created that does that work, and the two blocks are replaced by a call to the macro. That's all. So it shortens code if you have a lot of things that are repetitious. The same set of calculations. Block A appears several times in the program. That block A should be moved into a macro, and then a macro called in place of those blocks. Okay. So let me see. And did that one, did that one, yes. Okay. I think we're getting pretty much covered. Okay, one more thing. I put leave on the list of approved. And Leah is already there. This is a nice instruction. Here's where it's needed. Suppose you're making an assembly function, manager or whoever. And we're doing it orderly. We have a culture that makes a nice program out of this that's readable by non-assembly program. All right. Well, anyway, let's come to there's the license and all the other segments up here. Segment data, segment BSS, segment text, and it's common you do 16 pushes here. And then maybe there's some parameters passed in. So you save the parameters somewhere else. Move R14, RDI. RDI was passed in R15, comma RSI. Okay, and then there's a block that is going to call scanf. And you need space for the number to go. So maybe you have a couple pushes up here to create space. And you do it in pairs to keep it on the boundary and all that. Okay, so this goes on and on and on. And finally, you're going to exit. So wait, I missed something. Among these 16 pushes, you remember what the first one is? Move or SP. No, I got it backwards. RBP, RSP. And what's the next one? Push. I think I got them right now. Okay. Those are always the first two. The rest of the 16, you can pick any order. And when you come back to the end of all this, the tedious, I mean, I've done it myself. You go back and search through this to see that the number of pushes equals the number of pops. So you can return successfully. There's 16 pushes here, and there has to be 16 pops someplace. What if you didn't pop after every set of two pushes? You didn't pop it directly below it. Some people work that way, and it's okay, but you have to compensate for it down here. Okay. Um, Suppose several blocks had pushes, but they didn't have corresponding pops. Well, eventually you have to place enough pops to counterbalance those so that return can work properly. Okay. That's so tedious that they created an instruction to take care of this. It's called leave. Leave is supposed to occur just before return, and it checks pushes and pops in your function, and it pops away everything to set it back to where it was when it started. When it started was right here before any pushes happen. It takes care of that problem. It's a real convenience, but it hides what it's doing. Okay. That's the leave instruction, and now you know what it is. Um, you could have guessed that programmers around the world would have become so upset with having to debug pushes and pops that they wanted something to do it for them. And leave is now on the official list of acceptable instructions. But that comes, I come to think of it, what is it actually doing? Maybe I can show it by picture form. If you're writing code in C++ and you call a function, the entire activation record is created at the call time. It's all there. It's in fixed size. As long as that function is running, this is in fixed size. And when the function is finished, it collapses. The top of stack moves back from here. It goes back to where it left off. But this is C++ AR. But in assembly, the old top of stack is back here. A function is called, and pretty much you set it up yourself. we don't even have, we have an open end here. We don't know its size. What you do is you put the old RBP is pushed here. B. C++ does that too. The old RBP is pushed here. But we in assembly do it ourselves. It's always the first one of those 16 pushes. It's always the first one. And this is making sure that the old RBP was on the old activation record. This next line says bring it to here. When this is pushed, RSP is already here. And then our second statement is to copy RSP into the RBP. And so the two of them are pointing to the same place. So as you program the assembly function, you're doing now 15 more pushes. You're doing blocks that require pushings and poppings. The size of this activation record in assembly grows and shrinks as things happen. We have some pushes down here. And then you yourself pop them back to try to get back to the original state. And that's okay. But here, let's imagine it here. You're here. Here's RSP right now. The back end is RBP. And you say leave. It takes RSP and puts it back where it was at the start of this function. Why don't we programmers simply do move RSP from RBP? All that. The RSP top of stack is here, and we're done with this function. We have to kill off its activation record. You can just move this back to here, and then you have to pop RBP. That's the reverse of the two instructions that started this whole thing. The two instructions that started is push RBP and move RBP RSP. And this reverses it. Okay. But in clock time, this is probably takes more ticks than this one. So I guess leave wins because it's a single instruction, generally speaking, is faster than two instructions. Okay. Yeah. And notes. Macros are not required on this coming test, but they could be a convenience if you have it already written. If you already have a macro written that does the 16 pushes, hey, just copy it and reuse it. Okay. Does anybody have any questions? Okay. If you've been with me all through this semester, I don't think you'll find this a hard challenge. The test is not new stuff. The test is old stuff. And the biggest tool at your disposal is to scale it down. Rewrite that. Even if you left, if there's 7 things to be accomplished and you left out one major one, that's okay. There's nothing wrong with it. What's not okay is to take that 7th point and bomb it. It's by having a seg fault problem or some other worse thing. take it out of the program and submit everything else. Uh, uh, it's okay. You can turn in Tom Sawyer, not Tom Sawyer, Chris Sawyer's program if you want, but being aware that it's a 20 pointer out of 100. Of course, if you do something simple, it's you get a lesser points, but at least it shows that you made a program. Uh, oh yeah, yes, Mary. The concept test is in finals week. That's 3 weeks from now. This is your last program of this semester. The last one for you to create is Wednesday. There's no more programming after that um, that you have to turn in. Now you can work on assignment 6 just for the knowledge benefit, but nothing mandatory. In finals week, on the regular scheduled day for our final, will be a concept test, and that's different. That's not programmed. You know what it looks like. Anybody have any other kind of question? Well, looking back, I think we accomplished a lot. I think the semester did more than a surface view of assembly. You got really deeply involved uh, with assembly this semester. Assignment 5 is unfortunate. It it's not my style of programming. I like uh, library functions. I like to learn how to use them, and setting up their parameters in assembly teaches me how C++ would have done it. I think there's value in learning how to use library functions. We don't know what language they were originally written in. To my knowledge, I don't think their source code is open source, but I don't know for sure. We don't know what language they were written in, but that doesn't matter. We know how to use them from assembly. Um, Anything else? What do you want to know about? We did scan a lot of programs this past weekend. Back to 2023, I wrote a 2 sentence summary on every final program and every midterm program in all the classes since then, and picked out some things that I think are doable and representative of what we've been doing this semester. Um, I can't think of anything more. Uh, I'm thinking of leads. Download the list, the list of functions of, better said, the list of instructions doesn't explain how to use the instruction. It's just saying this is valid. Uh, if you know about these and the GPT program comes along, it's not going to wipe out your score because it's so much better. It too has to abide by the same list of approved functions. Uh, it's been a good semester overall. You may not think so after that assignment 5, but this is what assembly is like, except for an infantile, watered down version of assembly. You got the real thing this semester. This is how it goes. And I think you'll do okay. Okay, I'm coming to an end. Um, we'll see you on Wednesday. I assume most of you will be obviously using this as a take-home test. That's okay. After you're the best guy here. On it. Thanks.